I am Prajwala. I worked on a real-time productivity tool called Samepage, which is showcased at TechCrunch 15 in 2008. Now I am going to show you how we approach real-time collaborative thing in our product, which is different from the Google Meets. Let me explain our architecture. This is client 1, this is server, and this is client 2. Initially, client 1 server and client 2 will have the same data. Let's say the A, B, C, D, A, B, C, D, A, B, C, D. So initially, server will maintain the revisions. Clients also maintain the revisions. So initially, everything is at revision 0. So what will happen normally? Client will edit the data by saying A, B, X, C, D, and client 2 will change the data by saying A, B, D. First, client 1 will send data to server by saying add X at position 2, and client 2 will send data by saying delete C from position 2. So at this time, client 1 will increment the revision number at the client side 1 and send the data. Client 2 will also increment the revision number and send the data. When server reads the first message from client 2, it will check the revision number. So it is already having 0. So it will automatically expect the revision number 1. So client 1 will not have any problem. And server will send a message with the acknowledgement and with the updated data. Updated data A, B, X, C, D. So this will update to the client 2 also. So now server received another message from the client 2 with the same revision number. So now at this point, at this stage, server is having the data with the revision number 1. So server is expecting the revision number 2, but it received a revision number 1 data. So server will respond this client with the NAC. And so that client can detect that there is something wrong with your message, you will roll back. So actually, client 2 will detect the conflict when it receives a message from the server with the revision number 1. So it will roll back and it will update its data with the A, B, X, C, D. When it receives NAC, it will roll back all the operations. So at any point, client 1 is having the data A, B, X, C, D, and server is also having the data A, B, X, C, D. Client 2 is also having the data A, B, X, C, D. So this is how we maintain the consistency with the clients and servers.
We implemented a lightweight concurrency model which is different from Google Wave. The core of our concurrency model is a shared resource which can be acquired using a parallel locking mechanism. The shared resource can be edited in two ways, a single step edit and a two-step edit. Now I would like to show you the two-step edit process. In a two-step edit process, when a client requests for a lock on a node in an XML document which actually forms the basis of our applications, it issues a locking request to the server. Simultaneously, it allows the user to start actually acting upon the node. Depending upon the locking request, a response from the server, the response of the client is shaped. So for example, if the lock is cancelled by the server, the application reverts back to its idle state. If the lock is successful, then the user will be able to update the node's value or its state to the next level, and it returns back to the idle state.